couple of things to talk about before we start. So I just want you to know, guess how many weeks there are until spring break?
1,
2. That's right. So you guys are super close to spring break, but we have a lot of work to do between now and then. So there's a couple of things I want to chat about. Thing number 1 is our project. So the research project. You guys have signed up for a topic, and today you turned in a journal article. And most of you, the journal articles you found are fine. Maybe there's a couple of issues with citations, and I'll talk to you about it when I hand it back to you. So that is good. If you look on the syllabus, it asks for a second article for Wednesday. No. Today is not Monday. Today is Wednesday. But it asks for a second article for Monday. But I think we're going to hold off on that, and I'll have you turn it in next Wednesday. Does that make sense? So I have it on there. Task 2 is due Wednesday. It's different than what is on the syllabus, but I didn't think you would really care. Anyway, and so I want to talk about this a little bit because you are going to have, within the next 2 weeks, we're doing a lot of work on metabolism. We have another test right before spring break. And you need to gather together your sources for your project. So it is 4 articles or 4 sources per person, and you already have a journal article. You need probably like a website article, so you might use like RxList or PubChem. Those are pretty good sources with general information about topics. So you can have a website source and then 2 other sources. And you're going to need all of your sources together in like a week and a half. Do you know what I mean? So I would start working on that, especially, if you have a pocket of time, go to the library, start gathering together your sources. So 1 journal article, which you already have, a website, and then whatever you like those other 2 articles to be. Be sure they can be reference articles. So if you want to use like a nurse's drug handbook, you could do that. But be sure that you're getting copies of your sources as you go. So you're ultimately going to turn the 4 copies into me, highlighted, so I know where you're getting your information from. And be sure that you and your partner have kind of decided what part I'm researching and what part they're researching. Do you know what I mean? So it should be discrete. So maybe I'm learning about how the disease is working, like what is causing the issues, and maybe my partner is working on the treatments. Okay, and so that you have figured that out, that way you have your own research to work on. It doesn't really matter what your partner's doing, you're getting your 4 sources together. And so what you're gonna do for next Wednesday, a second source, it doesn't have to be a journal article, it can be your website article. That probably is the easiest article that will have general information about your topic, but you're gonna write me a half-page summary of the chemistry. Okay, and what I especially want you to be looking at is like what's causing the disease. Is it an issue with neurotransmitters? Is it an issue with an enzyme not working properly? Like, what is the issue? Or if you have a drug, how is that drug helping? And you want the chemistry part of it. Okay, that's really important. So you're looking for things like mechanism of action. Do you know? That's sort of what you're looking for when you're researching this. We're going to talk about drugs. And we're going to talk more about neurotransmitters on Monday, okay, while you're heating. And so we will talk about it on Monday, but that's something that you can kind of be looking at this weekend, and then you need to be getting together those 4 sources. Does that make sense? Okay, any questions on that? All right, well then let's talk. So you guys have out that page 79. It should say glycolysis on it. And this is our very first pathway. So what we're going to do is first fill out that page 79, and then when you guys are putting together your picture, I want you to go vertically with your picture, and we'll talk more about this before we get you started. So probably we'll fill out page 79 and then you can work on the picture, and we'll talk a little bit more about that. But when you fill your picture out, go vertically, and also try not to use more than half of the page for just glycolysis, okay? Because you're going to be filling out the bottom part of it later. So this is what's in your homework metabolism picture. We're just going to go through that one pathway, and then you guys will start working on it. Does that make sense? So I want to say a couple of things. For your exam, the next exam, I know it seems crazy to be talking about one when you just took one like 5 minutes ago, but crazily enough, we are. And for your next exam, you are going to get something that looks just like page 79. So do you see that it has the structures and it has the names? Does everyone see that? So what you're going to be doing is filling it out, and I'll probably ask you questions about certain steps. And notice, I think the steps aren't numbered, so you could also number the steps as we go. And there are blank pictures of glycolysis on Canvas, so you can print them out and practice. Do you know what I mean? Between now and then. And there's blank ones of Krebs cycle. We'll probably do Krebs cycle in class today. Okay, let's start with glycolysis though. So let me pull this down, turn this on. Oops. And I want to say a couple of things. So we're sort of leaping in to our first pathway, and we haven't totally talked about the main molecule. So I think we started this last Wednesday. We talked a little bit about metabolism. We said it's all the reactions in the body, and we're really going to start with what you get in your diet. You know, we're starting with carbohydrates, and we're starting with the carbohydrates that you would take in by mouth. And then what is the first pathway that they would sort of enter into? So that's glycolysis. We'll talk a little bit more about the basics of it and some of the introduction parts of it, but we'll talk, I mostly want to get through this pathway first. So there's a couple things. This pathway doesn't require oxygen, so it can happen in the body when oxygen is present or when oxygen isn't present. Okay, so it can happen at any point in the body. And I also want you to remember that the whole point of this pathway, like you want this pathway to be on if you're trying to make ATP. Okay, so you might like write yourself a little note. And the other thing I want you to know is that this happens in the cytosol. Okay, so we're going to be paying attention to where it happens and when it happens. So it'll happen anytime that you need ATP. Okay, so we need ATP, and it doesn't require oxygen. Okay, so I'll put that in this corner. It doesn't require oxygen. So sometimes people think that that means this pathway only happens when no oxygen is around, and that's definitely not true. Okay, it happens anytime. It happens when oxygen is around and when oxygen isn't around. All right, and so let's start with this. We're starting with glucose, which you should know. And how many carbons do you notice in glucose? 6, good. And so that's something that we're going to be following as we go. So we're going to pay attention to the number of carbons in each of each of the steps. Okay, so we're starting with a 6-carbon molecule, and the very first thing that happens is a phosphate group gets added. So do you guys see this little phosphate group here on the 6th carbon? So this is called glucose 6-phosphate. And anytime a phosphate group, almost always, anytime a phosphate group appears, it came from ATP. All right, so this very first step, we're taking an ATP, and it's being converted to ADP. What's the difference between ATP and ADP?
Triphosphate.
Yeah, one has 3-phosphate, one has 2-phosphate. So one of the phosphates groups was added to glucose. That makes glucose 6-phosphate. And you can number this step, number 1. And actually, if you want to go through like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you can go through and number the steps before we move on. I want you to put a little star next to this step. This step, that means it's a regulated step. That means that this is a control point, like I can turn this step on or off, and that's a way to turn on or off glycolysis. And then the other thing is, anytime you move a phosphate group from one molecule to another, the enzyme is going to be called a kinase. Okay, so the enzyme is called kinase. Okay, so I will probably ask you on the test, you know, like what is happening in step 1? And you should be able to tell me a phosphate group is being taken from ATP and it's stuck onto glucose. Okay, that's really all you need to be able to do, but be sure you can explain each step. I won't ask you about each step on the test, but you kind of need to know each step so that you can explain whichever one I pick. Does that make sense? All right, let's look at the next one. What do you see changing here? So we're going from glucose 6-phosphate, which has 6 carbons, and we're going to fructose 6-phosphate. So how many carbons in fructose 6-phosphate?
6.
Still 6, so we're not losing any carbons. Okay, that's important. We're going to pay attention to that too. And the phosphate group isn't changing. What is changing when you go from glucose to fructose? What is changing? There's something that's changing.
Aldehyde.
Yeah, we're going from an aldose to a ketose. Okay, so really what we're doing is this carbonyl group is moving. It's on carbon number 1, and now it's on carbon number 2. Do you guys see that? All we're doing is moving a functional group. So you can remind yourself, like this was an aldose, and this is a ketose, but really all that happens in this step is you move a functional group. And so the name of the enzyme that moves functional groups is called isomerase. Okay, and these enzyme names show up all over the place in metabolism. Okay, so just the second step, we moved a functional group, and the enzyme is called isomerase. Most of the time, these are general names of enzymes. So there's probably like a specific name, but we're just going to learn the general name. Okay, like this first kinase is probably called hexokinase, but we're just going to call it kinase. All right, let's look at the next step. So a couple of things happen in this next step. What do you see changing? First of all, do we still have 6 carbons?
Yes.
Okay, so we haven't lost any carbons. That's important. So we still have 6 carbons. What do you see happening or changing from the fructose 6-phosphate to the fructose 1,6-phosphate?
More phosphate?
Yeah, we added a phosphate group. Do you guys see this new phosphate group that shows up on carbon 1? Where do you think the phosphate group came from?
ATP.
Yeah, ATP. Just like a phosphate group over here, it came from ATP. That means I need an ATP in this step. So ATP is going to get converted to what? ADP, that's right. And what did we say was the name of enzymes that move phosphate groups? So they move a phosphate group from ATP onto this fructose. Yeah, it's a kinase. Good. So put that in. This is a kinase. Also, it's a regulated step. Okay, so put a little star in there. And then I also want you to label this the committed step. Okay, committed step. So a couple of things about this. One, the reason that this is called the committed step is that once I make this fructose 1,6-phosphate, once this molecule is made, then I'm sort of committed to going through glycolysis. This molecule is only in glycolysis, and so once you make it, then you're going to go through the rest of glycolysis. Does that make sense? So you're sort of like committed to doing that pathway. And I think I need to backtrack 1 second. I want to talk about this first step one more time. So I just want to say this. When you have, let's say you have breakfast and all of that starch maybe in your toast or maybe the milk that you had in your cereal. Anyway, the glucose that you produce in your, or you get in your diet, no matter what happens, that glucose gets brought into the cell, and this very first step will always happen. And the reason that that very first step always happens is that once it becomes glucose 6-phosphate, you can't use glucose 6-phosphate, like it can't come out of the cell. Do you know what I mean? It sort of locks it into the cell, and then the cell has to use it. But glucose 6-phosphate is sort of a hub, meaning that once I have glucose 6-phosphate, I can direct it towards lots of different pathways. It doesn't have to be used in glycolysis. It could be, but it doesn't have to be. But unlike when you make, say, this fructose 1,6-phosphate, once I make this, then I'm definitely going through glycolysis. Does that make sense? But no matter what happens, when you get glucose in your cell, it will always get a phosphate group added to it that locks the glucose into the cell. Okay, and then the cell has to do something with it. Okay, so we're here at the fructose 1,6-phosphate. It has 6 carbons. And the next little piece of this is it's going to split in half. And so we're going to get 2 3-carbon molecules, okay? And we're not going to worry about the enzymes that do this step, but the important part is it splits into 2 3-carbon molecules. So you make one of these DHAPs, and then you make one of these glyceraldehyde 3-phosphates. And the DHAP, if you want the abbreviation, or you want to know what the abbreviation stands for, it's dihydroxy acetone and then phosphate. Okay, but DHAP is kind of like our abbreviation. And we'll see that molecule again. So I make one DHAP and one glyceraldehyde 3-phosphate when this molecule splits in half, okay? The next step is that this DHAP is going to be converted to another glyceraldehyde 3-phosphate. So ultimately, how many of these glyceraldehyde molecules am I going to have? 2. So that's really important. So 2, 3 carbon molecules. Okay, so there's 3 carbons. 2 times 3 is 6, and that's how many carbons we started with from glucose. Okay, so from here on out, we're going to have 2 molecules. So go ahead and put those 2 in. Okay, so from here on out, you have 2 of these 3 carbon molecules. And so look at the DHAP, and I want you to compare it to the glyceraldehyde 3-phosphate. So the DHAP is like the top part of this 6 carbon molecule, and the glyceraldehyde is like the bottom part. So when you go from DHAP to glyceraldehyde 3-phosphate, do you guys see that they both have the CH2O phosphate? Like that part's the same. But the part that's different is that I have an OH on carbon 2 and carbonyl on carbon 1, and here they're in different places. Do you guys see that? Is this an aldose or a ketose? It's a ketose, and what's this one?
Aldose.
An aldose. So all we're doing is moving a functional group. What was the name of the enzyme that moves functional groups? Isomerase. Good. So I just want you to write that in. And if you want to write yourself a note about DHAP, that it is a ketose and that glyceraldehyde is an aldose. But the important thing in that step, you're just moving a functional group. And so the enzyme is called isomerase. Okay, isomerase. Good. And so from here on out, there's 2 3-carbon molecules. Okay? And so now I'm looking at the glyceraldehyde, and I want to look at what happens in this next step. So there's 2 things that happen in this next step. What's one thing that you can see happening? So like from the glyceraldehyde to this 1,3-bisphosphoglycerate, what's one thing for sure that you can see happening?
Phosphate.
We're getting a phosphate group. Okay, that's good. And then, so this time it's different. I know we said in general, like if you see phosphate groups appearing, they come from ATP. This is the only time it doesn't. And so on this step, there's a couple of things. So like we're gonna write step 1, we added a phosphate. I'm just gonna write P for phosphate. And this phosphate comes, we sometimes write it like PI for inorganic phosphate. So it's just phosphate, free phosphate that is in the cell. I need 2 of them. How come I need 2 phosphates? Because I have 2 molecules. Good. So I'm just going to write 2 and then this PI. Okay, that just means 2 phosphates that are in the cell. Okay. Then there's a second thing that is happening in this step. I want you to look at this hydrogen in glyceraldehyde. Do you guys see that hydrogen? Do you see it up here in the product side?
No.
Okay. So did I gain a hydrogen or did I lose the hydrogen?
Lost.
Good. And when you lose a hydrogen, does that mean you are being reduced or are you being oxidized?
Oxidized.
I'm being oxidized. Okay, that's really important. So the glyceraldehyde is being oxidized. That means something else has to be reduced. Okay, remember that they go hand in hand. And so we talked about this last week on Wednesday in class. We said that if you have a redox reaction, then you have to have a coenzyme involved. So either NAD plus to NADH or FAD to FADH2. So how many H's do you guys see there? 1. Just 1. So do you think we're going to have NAD plus or FAD? FAD will carry how many hydrogens? 2. And how many hydrogens do I have? Just 1. So which one only carries 1 H? Good. So this is the second thing about this step is that this is a redox reaction. So the glyceraldehyde is being oxidized. That means I need a coenzyme to be reduced. So NAD plus, and there's 2 of them, 1 for each molecule. So 2 NAD plus are going to be turned into 2 NADH. Okay? So we added a phosphate group, inorganic phosphate that was in the cell, and then the second thing is it's a redox reaction. And so I also want to give you the name of the enzyme. Anytime you have a redox reaction, the enzyme is called dehydrogenase. And so you just spell it DE, hydrogen, and then ASE. Okay, let's see if I can fit that in there. Maybe not with that color. of times when we're filling these out, we'll just abbreviate dehydrogenase with like DH. Okay, dehydrogenase. That's the name of the enzyme. All right, and so now from here, we have the 2-bis phosphoglycerate, and we're making this 3-phosphoglycerate. So what do you notice happening from the first molecule here, so this guy, going over to this one? What's missing?
Phosphate.
A phosphate group. So this time, a phosphate group is taken away from the molecules. You guys see this top phosphate group? It's not here. Okay, and this is the very first time we're going to make ATP. So in this step, I'm going to have 2 ADP, and those get converted to 2 ATP. How come I have 2 molecules of ATP? Because I have 2 of these, right? Each one of those has a phosphate group on there. So again, we're moving a phosphate group. So what is the name of the enzyme that moves phosphate groups? Kinase. Good. So put that in. And then there's one more thing that's important about this step. This step is called a substrate level phosphorylation. So I'm going to abbreviate that SLP. That stands for substrate. And we used that word before. What does substrate mean when we're talking about a reaction? Who is the substrate? We talked about this last Wednesday. Is the substrate the reactant or the product? It's the reactant. The substrate is a reactant. So I'm taking a phosphate group from the substrate and I'm adding it on to ADP. Anytime that happens, the phosphate group is removed from the substrate, and it's called substrate level phosphorylation. Okay, that's what that stands for. All right, so then next step. What do you notice happening from, let me move this up a tiny bit, the 3-phosphoglycerate to the 2-phosphoglycerate? If you look at them from the top down, like the top carbons are the same. What's happening here between carbon 2 and 3?
Phosphate's getting moved.
The phosphate's just moving. Do you guys see that? So the phosphate group is on carbon 3, and now it's on carbon 2. So we're moving a functional group again. And so we said before, if you move functional groups, what was the name of the enzyme? Isomerase. But this one is not called isomerase. It's called mutase. Okay, mutase. But it's like an isomerase, but just it's different. So called mutase. Okay, but all that's happening in that step is you're just moving that functional group. All right. So next one, I want you to pay special attention to these bottom 2 carbons. Okay, so those bottom 2 carbons and then these bottom 2 carbons. All right, look at carbon number 2 in the 2-phosphoglycerate versus carbon number 2 in the phosphoenolpyruvate. What is missing from carbon number 2? An H. Okay, so there's an H missing, like I'm going to circle it. And then look at the bottom carbon. What is the bottom carbon missing? An OH. So what does that make? Water. Am I adding water or am I removing water?
Removing.
Okay, good. So that means one of my products is going to be 2 water molecules. Okay? What is that called when you remove water? Is that called a hydration or a dehydration?
Dehydration.
Dehydration. So really, you're just going from an alcohol, do you know, to an alkene. Okay, so this is a dehydration. I'll write it right here. And how come there are 2 water molecules?
There's 2.
Because I have 2 molecules of that phosphoenolpyruvate. Okay, next step. What do you notice when you go from the phosphoenolpyruvate to the pyruvate? What's kind of leaving?
Phosphate.
Yeah, again, here's that phosphate group it's leaving. I'm taking the phosphate group from the substrate, and so what do you think we're going to be making in this step? We've seen this before. What happened like in this step up here where a phosphate group was removed? We removed that top phosphate group. What happened? Where did it go? Where did that phosphate grow in this step? Yeah, I made ATP. So where do you think this phosphate is going to go?
Into the ATP.
Yeah. So I'm going to have 2 ADP, and those will be converted to 2 ATP. Okay, this is a regulated step, so put a little star on there. What's the name of the enzyme that moves phosphate groups? Kinase, that's right. And is this substrate level phosphorylation? Am I taking a phosphate group from the substrate and putting it onto ADP?
Yes.
Yeah, that's substrate level phosphorylation. Good. What is this one up here? Let me ask you about this one. When we went from glucose up here to glucose 6-phosphate, is this substrate level phosphorylation? Are we taking a phosphate group from the substrate? No, we're adding it onto the substrate. That's different, okay? All right, a couple of things. So this is sort of the end. I want to write what we make all together. So we started with 1 glucose, and how many carbons were in glucose? 6 carbons. And we made how many molecules of pyruvate? This is pyruvate, this N molecule. So 2 molecules of pyruvate, and that makes sense. So there's 2 3-carbon molecules. That makes 6 carbons, and that's how many we started with. Okay? How many ATP do we make? So look at your pathway. How many ATP do we make? 2. How come 2? Because I see 2 ATP at the end here, and I see 2 ATP right there. That's 4 ATP.
So you use 2.
But I used a step here, right? Do you guys see at the very top, we used an ATP here, and we used an ATP here. Do you see that? So I made 4 altogether, but I used 2. So how many did I make? Just 2. Okay, so let's put that in, 2 ATP. What else do we make? 2 more things. What else do we make? There's 2 more things. Can you see it in here? 2 more products. Yep, 2 molecules of water. And something else. NADH, 2 of them. And I want you to write yourself a note underneath those NADH. Write yourself a note that they're in the cytosol. Okay, that becomes important later. Okay, so those 2 NADH are in the cytosol. Okay, how many substrate level phosphorylation steps do you see? 2, good. So the last step is substrate level phosphorylation, and then this other step here. So the 2 steps where you're making ATP, those are substrate level phosphorylation. How many regulated steps are there? 2 or 3? Okay, so it's the very first step, right? This committed step, and then the very, very last step. Okay, and so when I say regulated, I just mean it's a control point. It's a way to turn a process off or on. It's kind of like when you take a shower, like in the morning or whenever you take a shower in the day. You take your shower, and then when you're done with the shower, do you leave the water on so it's available for you like the next time you want to take a shower, or do you turn it off?
I'll turn it off.
You turn it off. Why don't you leave it on? You don't want to waste water. And it's the exact same thing with glycolysis. I don't want this to be on unless I need ATP. If I need ATP, I need to be able to turn this on. But if I don't need ATP, then I need to be able to turn it off. Okay, that's really important because I don't want to waste my glucose. Do you know what I mean? You only use it, we only want this pathway on if we're going to make ATP. And it's not a whole lot, right? We only make 2 ATP, but it's their very first step in the pathway that's going to produce us a lot of ATP. Does that make sense? Okay, so one more thing. We're talking about glucose, but really, that's not what you're getting in your diet. Do you know what I mean? So like, let's think about what kinds of carbohydrates you might get in your diet. So what would you get? Let's think about it. Like for breakfast, what could you maybe have? Cereal. And if you had cereal, what kind of carbohydrates are probably in it? Okay, what would sugar be? Like what's the real sugar name for sugar? Sucrose. And what is sucrose made of? Glucose and fructose. Okay, so what happens if I get sucrose in my diet, then what enzyme is going to break it down? Sucrase, and that will end up as glucose and fructose. And glucose will feed right in to our main pathway in glycolysis. We'll talk about what happens with fructose in a second. What else could you get in your diet? Like if you have cereal, you probably don't have dry cereal. And so what else do you put in there?
Lactose.
Good. And what's lactose made of? Galactose and glucose. So again, if you have lactase, you're not lactose intolerant, but if you have lactase, then that gets broken down into galactose and glucose. And glucose feeds right into the metabolism pathway. And I'll show you where galactose goes in a second. Okay? What else? Like your cereal probably isn't all sucrose. What does it probably have in it? Starch, which is made of what too? Good. Isn't it so nice? You just took a test on this? And what are those all made of? Glucose, right? Totally. What if you have banana for breakfast? What do you think that is? Fructose, right? Which is something we already talked about. What if you have toast? Well, that's probably amylose and amylopectin, right? So any carbohydrate that you can think of that you get in your diet, it's really going to end up as either glucose, fructose, or galactose. All right, that's where it goes. Has to be one of those three. And then we've already talked about where galactose ends up in the pathway. So really, or it's not galactose, but glucose. So really, we just need to talk about where do galactose and fructose go. All right, and so let's do that. And then I think we're in a good place. So we know glucose is the starting point. Oops, you can't read that. Hold on, let me move that. Oops, not like that. There we go. So glucose is the starting point. Glucose will feed in here. Where do you think fructose will feed in at? Yeah, where it says fructose 6-phosphate. What do you think has to happen to the fructose first?
Add a phosphate.
We have to add a phosphate group. So I want to point this out. If I feed in here at fructose, sometimes people think, well, it skips this ATP step. But before fructose can become fructose 6-phosphate, it's going to need a phosphate group. Does that make sense? So these numbers that you're getting from glucose are the same if we were talking about galactose or, what you get from glucose are the same as what you get from galactose or fructose. Still 2 pyruvate, 2 ATP, 2 waters, and 2 NADHs. It doesn't matter what monosaccharide you start with. Does that make sense? And so maybe just put yourself a little note if you can feed it in there, but fructose will typically feed in right there. And galactose will typically feed in here as glucose 6-phosphate. So there's a couple of steps we're skipping. Like first galactose will get phosphorylated and then it will be converted to glucose 6-phosphate. I'm not going to show you that step, but the important part is all of the monosaccharides will still feed into glycolysis and your products that you get from those monosaccharides are still the same. Okay? So what I would like for you to do with your metabolism picture is, I'll put that back on. What I would like for you to do, we're sort of just looking at the very first piece of this, and so I want just glycolysis. And so there's probably 3 pathways we're going to stick on here. Well, actually maybe 5 altogether, but anyway, but 3 main ones. And so I kind of want glycolysis to not take up more than half of your page. Does that make sense? So if I were you, I would probably draw the structures, maybe put the names on, and then you just start filling it in with the steps. Where do I use ATP? Where do I make ATP? Is it a regulated step? Is it not a regulated step? And then just get as far as you get. If you don't finish today, it's fine. Like you can work on it between now and Monday. But we want to just go as far as we possibly can. If you are a person that is like, I want to write this as big as I possibly can, and you want it to fill this whole page, then you can put glycolysis on 1 page, but you're going to need a second page for Krebs cycle, and then what you'll do is just tape them together. Do you know what I mean? It'll just be one long big one. But it might be nice to make it sort of smaller. Whatever you like. It doesn't really matter. But anyway, try it. If you're going to only use 1 page, half the page. All right? And then, so there's colored pencils. There are some Sharpies. If you just want to do it in pencil first, and then you want to color later, you can. Like, whatever you like. It's your picture, right? This is your picture. All right, good. So I'll turn this off, and you guys get started.
She does it pretty good.
Copying it.
No.
And there's, oh yeah, I was gonna say, there's lots of different colors.
Yeah, it's like electronic. Right, so is that gonna go on the back or something? No, you're supposed to put it on there. So would we want to use a third of the page?
These are going Oh, that's blue.
Why?
What? Why is that? What? Now you want me like, why is it how you do this?
Yeah.
On the test, you're gonna give us the name on the
I'm
bottom.
doing the names.
So exactly this page
It's
is
gonna
like.
look just like that.
Okay.
Yeah. I just call that form. Yeah. And then 5.
That's the last one.
Yeah, just count that as like your number.
I'm gonna write.
You know, like alcohol codes that like change.
Yeah,
They're like, we don't have to do these really
Oh, God.
Then 6.
My head's so bad. I feel like I'm gonna throw up.
I want Sharpies.
Yeah. So I would draw the structures. Yeah, I would draw the structures, probably put the name on. Yeah.
Are we doing this the rest of class?
Yeah.
I'm gonna be so anal about this.
But I also want.
I think that what I'm gonna do. I think what I'm gonna do is I'm just gonna sketch it all out.
Yeah, I'm gonna do the puzzle first.
That's like my practice study.
I'm literally gonna have a wall in my office.
Yeah, but like write in pencil on the sheet.
So do you guys see this big poster? That, well, it's not that big. But do you see this one that's kind of up here on the side? This is kind of where we're going. So like this is someone from a previous Chem 2B class. So here's the glycolysis part. This is their picture.
That's all they wrote.
Then we'll do the pyruvate and quick cycle and electron transfer. The whole thing. That's ultimately where we're going. So you just want like this glycolysis part right now.
It's like the same size as all these papers.
Was that right? Absolutely. You have one in your locker.
Oh, I do.
You do.
What do you use this one?
I do have one in my locker. What's my locker combination?
What am I doing? I can't get the wall.
That is it. Okay.
I didn't even look. It's the first time I've ever been able to do that. Just for the record, everyone. I never. That one's. Yep. Just drawing this for now. Just gonna fucking do it. Just gotta get it really kind of just one white paper.
It's definitely
Because like then I can like put my colors with it. Oh, glycolysis. You gotta have title first. Oh, types are crazy. You gotta write. Oh, types are crazy. I don't. Do I really need to have it? Yep. Why? Because why not? Oh shit. Groups of them. I told you I. It makes control light. Because everyone's really focused. Anyway, so we're just gonna sketch it all there. So should I do each of these a different color? Or should I do it all the same color and just change the colors of things that are changing?
I would like what I'm gonna do is like color code like steps. It's like I'm gonna color code the like ACEs, all the enzymes, and I'm gonna color code like why those steps and ACEs. So I wrote like what's happening at phosphate. Molecule splits into two. So I'm gonna color code those and like ATP. Yeah, that's what I'm.
See, I don't really know when steps are happening. I don't think I remember them correctly.
No, you did it on the arrow.
That's what she did.
You are wrong.
On the arrows. Yep, so there should be 10 altogether. So 1, 2, 3, 4, 5, and then 6. You're stopping me. Yeah. Yeah, it's okay. There's a lot of stuff like that. Yeah. Got it.
Because that's like what's when the stuff's happening, essentially. Okay. Everyone is really quiet. This is like so weird. I don't know what to do right now. Like, can we just like talk about this? Can we be friends? Yeah. I don't know how to. We're friends. I don't know.
I did not get on your aspirin lab when you turn this in.
That's
it
right.
didn't have the pre-lab, like the original pre-lab that I signed attached.
So,
So can you track that down? Because otherwise I
What do you
can
think about
finish grading it. So I have a couple people that when you turned in the optical isomers lab, I did not get your pre-lab, and then that meant I couldn't finish grading it. So if I call you, that means I need you to track that pre-lab down, and I need you to attach it to the lab. And so let me find that. So like Amy with an
stuff that's being
L,
added.
and
I think
So I can like see what's happening.
yeah, and it's page 50. So it's like literally the page right before that. Jackie.
Because like when you draw,
I'm just looking, it should be
you
page
draw
50.
like whatever you
Highlight
I'm sure you
like,
did it.
keep drawing.
I just need you to
Oh, it's
track it down.
My color
And then
pencil, like, it's on my right
Hannah,
over the rainbow. And the sharp
Cheyenne,
is underneath the color thick. So I'm gonna trace that.
James.
I'm thinking like this, and then should I do like
You
maybe, like
are
highlight what's
missing
changing,
like the last two
and then like write
pages
the
of
steps in a
the
different color?
lab. You have the pre-lab, but you don't have the pages of the lab. You only see
This is my rough draft.
yeah, and it goes to like 55. So I just need you to find that pre-lab, Cheyenne. Gilson, page 50. That probably goes with the
Do
aspect.
we need the names of them all? Oh yes.
That should be.
Yeah.
I don't know how to step, right?
Yes. I just need you to find page 56.
My brain hurts.
Step.
She doesn't. She just forgot how to spell step.
That's right.
Cool.
That would be
Sorry,
very awesome.
No, I erased it to make it bigger.
And then I have another
Rosie-
one, but it has no
Rosie's
name on it. I'm not 100% sure. If you don't get your optical isomers lab back, maybe it's you.
But we don't need it anymore. Rosie. Rosie.
You may not, that's, I don't think I called the name from last week. Yeah, no, that was like from last week.
I did 63 to 75.
Yeah, that lab is what you turned